Hello, this is Dave Strensky from Solar Ipsy, and today's going to show you a short video to kind of explain net metering and how it works today, how it worked in the past, and how it might work going forward. Let's pretend that this is my house. It's 4 o'clock in the morning. Let's just say that it's the middle of the night, and as you can see, there is no sun, and the solar panels are not receiving any sunlight, so they're producing no electricity. And this red box here is the inverter, and the inverter is totally shut off, and I'm getting all of my power from the power company, from DTE in my case. So all the electricity that I need to run all of my appliances is coming from DTE energy, coming into going through my utility meter into my breaker panel and supplying electricity to all the appliances in my house. My meter is running forward, and I'm paying some number of cents for every kilowatt hour that I receive. Now, as the morning comes, the sun has just risen a little bit. It's at a very shallow angle to the solar panels, but they do start making some electricity. This inverter will wake up. It will listen to the type of electricity that's being generated or that the utility is generating, and so it will produce a little bit of power that exactly matches the electricity in your house. So at, say, 8 o'clock in the morning, I might have enough solar electricity to power my toaster, but all the rest of my appliances are still being supplied by power from the power company. And as the sun rises, I'm going to be making more and more power, and I'll get to my maximum power when the sun is directly over the solar panels. So let's say at 11 o'clock, you can see I'm making more electricity, and maybe 4 of these appliances down here are all powered by solar electricity. Maybe my microwave oven here is still using a little bit of DTE energy, but most of my house is solar powered, and I'm buying just a little trickle of power from DTE at, say, 11 o'clock. Now let's assume that this is a good day. It's 1 o'clock in the afternoon, just afternoon. It's a sunny day, and I'm making a ton of power. So the solar panels generate their direct current. It comes in, the inverter converts it to AC, or alternating current, for my house, and I have totally supplied all the electricity in my house. All my appliances are totally satisfied with solar electricity. And I have a little extra power that's now coming in, and it's coming into my breaker panel, and there's no place for those extra electrons to go because everything in my house is satisfied. So the question I always get asked is, well, where does that power go? Well, it flows just like water, and it's going to go from my breaker panel, and it's going to flow backwards through my utility meter and back out to the utility grid. And this is the kind of the magic that happens here, is that the utility meter doesn't really care. It's just wherever the least path of resistance is where this electricity will go, and my utility meter will spin backwards. If it's one of the old type with the bladder, it will you'll see that little disc spin backwards. The newer smart meters, they reprogram so that you have 2 readings now, one to measure the power coming into your house and one to measure the power going out of your house. So this is how it works. Now let's talk a little bit about the money. So today, 2016, we have what's called true net metering. So, and I'm just, this is a rough guess or estimate because the prices changes all the time. But roughly in 2016, it costs about 16 cents a kilowatt hour to bring power into my house. And with true net metering, I can push out my excess power at the same price. And what this means is I can be totally solar powered. I can push out extra electricity during the sunny parts of the day, and I can bring that electricity back in at night to power my house when there is no sun. But at the end of a year, we can say that my house is 100% solar powered because I have produced all or an equivalent amount of solar power that I've used in my house. And this is terrific. This is a great way to go. When I started in 2005, we had net metering, but it wasn't true net metering. And what that meant is that you would buy at one rate, let's say 16 cents per kilowatt hour in this example, but when you sold it, they gave you credit for the electricity, but not for the transmission fee or some of the other fees or accounts and stuff like that. And so while this wasn't, this is not as good as it is today, it wasn't actually that bad. It changes your economics a little bit, and the time it takes to pay for your solar installation is a little bit longer when you have something like that. The trouble we have today is they want to change this, and look at the picture now and how the power is directly connected to my house. They want to change that picture to this picture. And what this means is I have to now add a second meter, and any electricity that I generate does not go into my house at all. It has to go out of my house. I get metered for it, and I have to sell it at wholesale prices to the utility company. So I'm basically the same as a coal or a nuclear fired power plant, and I'm selling electricity to the utility company for the same price. And it might be as low as, like in my example here, maybe like 4 cents, because it's all the wholesale price. And then I would then have to bring it all back in at the regular retail price, which I'm using as 16 cents in my example here, to power all my appliances. So this drastically changes the economics. And I don't see how this makes sense, because adding solar panels to my house just means I'm using less electricity. And it would be the same as if I just turned everything off in my house. So how is one house different from another house? If I have two houses side by side, one installs solar panels and one just shuts everything off in their house, they should be treated the same. Here, they're not. I would have to send all my power out at some cheap price and buy it all back at a higher price. So now the following question comes up is, it goes back to the grid. What does that mean? People think that this electricity has to go all the way back to the power company, and it doesn't. So here's a picture of our neighborhood. We have a power plant of some sort, many miles away, and we have some power poles, and we have transformers in our alleys. And I want you to kind of imagine a person at the power plant with a giant pile of coal, and you picture somebody shoveling coal into a furnace. That's kind of how it works. And there's a giant meter on the wall, and when the meter starts to go up, it says, "Oh, I need to make more power." You shovel the coal a little bit faster. When people go to bed, the meter goes down. I shovel a little bit less coal. And so this coal-fired power plant, let's say, is supplying electricity to the whole neighborhood. Now down here in the lower left-hand corner, let's assume that we have two people here, and they've added solar panels. Like my previous example, it's a nice sunny day. They're overproducing the electricity that they need for their house, and they're actually supplying electricity to this other house to power, their toaster. So what this means is that this excess solar power is not going back to the utility company. It's looking for the closest ground. It's looking for the closest place to be useful, which is your neighbor's house. And so your electricity that you overproduce during the sunny parts of the day doesn't go any further than maybe 50, 100 feet to your neighbor's house. But what this means is the person over here that's shoveling coal into the power plant doesn't have to supply electricity for this portion of the grid. So the needle drops and they shovel a little bit less coal. So this is how it works. And you can imagine if, this neighborhood and maybe the neighborhood up here and maybe the one over here, if they all had solar panels, maybe during the peak hours of the day, and we're kind of doing the power company a favor by reducing the peak demand for electricity during the sunny parts of the day when everybody's running their air conditioners. Solar panels are perfectly matched with like air conditioners. When you have your brownouts and blackouts, it's because people are asking for a large amount of electricity, and solar panels would be making their most electricity at the same time. So we're kind of reducing the stress on the grid. Anyways, this is how it works. Hope this is easy to understand, and you can contact me at Solar Ipsy if you have any questions. Thank you.